In this lesson, 5.1, we're going to talk about triangles and some of the angles within a triangle and some of the angles in the exterior of a triangle. So the first relationship, we're going to just start with some review of naming. And so naming it by its angles, if all the angles are less than 90, then it is an acute triangle. If we have a 90-degree angle, then it is a right triangle. If we have an angle that is greater than 90, it is obtuse. And if we have all equal angles, then it is equiangular. And this next one is not by angles, but by the sides of the triangle. And so if we have at least two sides that are congruent, it is an isosceles triangle. The base angles are going to be congruent, which are the angles that are opposite those congruent sides. If all three sides are congruent, it is called equilateral. And if it is equilateral, we actually have an equiangular as well. And vice versa. If it is equiangular, then it is also equilateral. And last one, if all three sides are different, it is called scalene. If we are looking at the interior of a triangle, all three angles in the triangle always total 180 degrees. And that is called the Triangle Sum Theorem. If we have what's called an auxiliary line, that can help us know what things are going to add up to 180 because it forms a line. And we also, if we have parallel lines, have some maybe alternate interiors such as angles 1 and 4 and 3 and 5. And if you remember that alternate interior angles are equal or congruent to each other, taking a look at angles 4, 2, and 5, these three form a line. And so what do we know must be true about them? They add up to 180 degrees since they form a line. So now if we go through 4 and 3, we're going to circle whichever ones would be true from our picture. Are 4 and 3 alternate interior angles? No. Are 4 and 5 alternate interior angles? No. Are 4 and 1? Yes. Are 5 and 3? Yes. 4 and angle BAD. Here is angle 4. And here is angle BAD. Do they form a linear pair? Together they form a line, so yes. And do they, or are they supplementary? Yes, they would be if they form a linear pair. So this project was just taking three angles of a triangle and putting them together to show that if we put them together, angle 1, 2, and 3, it would form a line which would show that all three angles in a triangle add up to 180 degrees. So with that triangle sum theorem, we're going to take a look at these two examples here. And so for angle 1, this one, we can't use our triangle sum theorem because we have two missing angles in this triangle, but we do have a relationship here that is a linear pair. And so for 180 for the total, we would subtract the 57, and the measure of angle 1 is going to be 123 degrees. And I always suggest that once you know what the measure of that angle is, that you write it in to the picture, because that might help you now to find other angles, such as angle 3. We know that these three angles, 28, 123, and 3, total 180. So we can subtract the two that we do know, to get the measure of angle 3, which would be 29 degrees. And lastly, we know these two, so we can find the third by subtracting the two we know from 180 and getting 52 degrees for measure of angle 2. So start with any triangle that you know two of the angles, so we can't start with 4 or 5. Can't really do anything here, but look at this triangle. We have these two. We could figure out what the measure of angle 7 is, since we already know two of them. So 7 would have to be 57 degrees, and I'm going to go ahead and put 57 in there. And then I'm going to look for my next relationship. Well, I have a linear pair here. 6 and that 57 form a line. So for the measure of angle 6, I'm going to take 180 minus 57. And I know the measure of angle 6 here is 123. So that would make 5 vertical to 57, or a linear pair with 123 again. So we know that the measure of angle 5 would have to be 57 degrees as well. And now I have two angles in this triangle over here that I can find the measure of angle 4 by subtracting these two that we do know. So 4 would have to be 56 degrees. And then the last one, we want to figure out, well, last two are 8 and 9, which are congruent because they have the arc marks. And so if we know the top angle, I can figure out what's left for each of these and then just split that in half. So we know that's going to be 57. And then I'm going to go ahead and take 57 and split it in half to figure out what each of those angles 8 and 9 would be, which would be 28.5. The second project is looking at the exterior angle here. And so we cut out this angle and this angle, which we call the remote interior angles. And if we put those remote interior angles together, they actually add up to the exterior. So two remote interior angles add to get exterior angle. So here's my exterior angle. If I were to add 1 and 3, then it would total 4. 1 plus 3 would equal 4. So in this example, I always kind of think of it like a TV. Here's my TV, and I'm going to use the remote being far away from the TV. This one's not the remote because it's right next to the TV. And this one would be the remote. We would use the remote from these two spots for kind of the TV. So we're going to add these two angles, the two remote, and it's going to equal the exterior angle. So x plus 65 equals 2x plus 10. And then I'm going to solve. There's no combining, so I'm just going to go ahead and subtract the x and subtract the 10. And I've got x, but I want to find the measure of ACD. ACD, this angle here, which is 2x plus 10. So I'm going to go ahead and plug my 55 in for x and then simplify. So 120 degrees for angle ACD. If you'd like to try this next one, go ahead and try setting it up. What two things do you add and set it equal to? And then plug it back in to find FLW. Add the two remote interior, set it equal to the exterior. And then solve. X is equal to 80, and then we're going to plug it back in to find this exterior angle FLW, which is 2 times 80 minus 48, which ends up giving you 112 degrees. The last part are corollary, which I call them common sense corollaries. Basically, it's leading a theorem that leads to another theorem, and it can prove it directly. So if we have a right triangle, the acute angles would have to be complementary. And if we know that a triangle always adds up to 180 and one angle is always 90, how much does that leave for your other two angles? Well, it only leaves 90, which means complementary. So these two would have to always add up to 90, and that's kind of why we call it common sense. The last one, there can be at most one right angle or one obtuse angle in a triangle. So again, total of 180. If I subtract 90, I only have 90 left, and that has to go for two angles. So neither one of these can be anything bigger. It would have to be like 89 and 1, and even that really 1 degree, teeny tiny. But you still have to have enough for an angle over here. Can't just have two angles in a triangle. There's always three. And then what if I had an obtuse angle, meaning something larger than 90, like 91? That only leaves 89 left. You can't have another obtuse angle in a triangle. It's not possible. So those are your corollaries.